Hello. This segment is going to be dedicated to learning about the shaded pole motor. In this segment, it's my intention to cover the method of operation, the components, or how it's made, as well as some of its operating characteristics. The shaded pole motor, as we see here, is a very simple motor. It is a single phase motor operating on AC only. Now, this type of motor, there's at least 3 to 4 of these types of motors in your household. Where you'll find them mostly are in small operating appliances such as a desktop fan. These desktop fans are ideally suited. One of the reasons is the shaded pole motor is extremely quiet. So you'll see it in certain applications in your household where noise is a real consideration. That being said, they're not known for having an awful lot of torque. And what we're going to talk about is how do we establish a turning force inside of the machine? Now, we're going to be referring to the Delmar textbook, Unit 34, and this is the 6th edition. So if I turn it over, and this is what I want to cover right here. I'm going to take a moment and I'm going to go and look at taking this apart, and we're going to examine the stator of this machine. Don't go away, I will be right back. So we're going to go ahead and start taking this apart. First things first, I'm going to grab the fan, pull that off, and I just happen to have a battery drill. We're just going to withdraw the 2 bolts. Very simple in construction. So there's one, and there's number 2. Now, this comes apart an awful lot like a squirrel cage induction motor. It's extremely simple in construction because what we have right here, just got to be fairly delicate here, is an end plate, which also features your, and I'm just going to turn this around. So this is considered to be a bearing, but it's a solid piece of bronze material, and it's embedded. So just below this disc is a fiber disc that's soaked in oil. So these are impregnated with an oil, and it'll keep this lubricated for many, many years. Now I'm just going to grab the rest of this, and here's the rotor. Now, if that was the drive-in, this is your opposite drive-in. Notice that the hole does not go all the way through. And here is your rotor. There's your output shaft, your drive-in, obviously, because we can see the splines. And you'll note that it is very much like that of a squirrel cage induction motor or a single phase motor, is that we have a laminated steel core made up of several laminations of steel, and it features aluminum rotor bars. You'll notice that the bars are at a skewed angle, which helps with the operation being so smooth. Now I'm going to set this down, and I'm going to pick up the stator. Now here's your stator. Now the stator, the shaded pole motor, gets its name from the fact that it's got 2 shaded areas. What happens is you've got this single coil that your alternating current input, because of the fact that you've got a sine wave, and that sine wave is oscillating positive to negative 60 times a second. So we have a cutting action. That cutting action is actually inducing magnetic flux that's flowing all the way through this ferromagnetic core. But in the areas at, let's call that, was that 11 o'clock and 5 o'clock. According to your textbook, what's happening is the magnetic flux is also inducing or cutting into these shading coils here and here. Now on this particular motor, you'll notice I've got 2 coils. So that means I've got an area where I've got more induced voltage here and here. And this creates that magnetic flux or a phase angle in the magnetic flux and the coil and the magnetic flux circulating throughout the steel. And this is what we attribute developing this rotating magnetic field. Remember that there's three criteria for establishing a rotating magnetic field. We depend on the strength of the magnetic field of the stator, the strength of the magnetic field in the rotor, but also the phase angle in the magnetic flux. And here we have magnetic flux in the shading coil, as well as the magnetic flux flowing naturally throughout the stator body. What I've done to be able to demonstrate the amount of torque that this motor can produce is I've actually placed it and I've immobilized it inside of my shop vise. I've added some tape just so we can see for visual reference how fast things are spinning. You'll notice it already comes with a termination. So I'm just going to go ahead and apply 120 volts to it. And you can actually see it's turning. But the amount of torque that this machine can generate is extremely weak by comparison. Why is it weak? Is because of the fact that we have very little phase angle difference in the stator because of the placement of the shading coil. And here's proof. I can actually grab it with my two fingers, and stop it. Now, I wouldn't dare do this with a three-phase motor or even a split-phase motor. Chances are I'd actually hurt my fingers. But with the shaded pole motor, there's no danger to me. And this is the whole point, is the fact that the shaded pole motor, the way the stator is set up, we depend on a phase angle difference between the magnetic flux in the stator and the shading coil. And when there's not a lot of phase angle difference, you don't produce an awful lot of torque. And this is evidence of that. One of the characteristics I wanted to mention about this motor, we've always considered a segment about can the direction of rotation of a motor be reversed? Now, in general terms, the shaded pole motor is considered to be non-reversible. This particular motor, however, could be reversed. Now, I'm going to cover this. I just want to verify with you the direction of rotation. I'm just going to tickle it with a little bit of voltage, and we can see that the direction of rotation was counterclockwise. Now, what I'm going to do is pry off the fan, and I'm going to grab a pencil, and we're going to put a little X here. According to the theory, I can actually take this apart, and if I turn the stator 180 degrees and reinstall it, the rotor in the same orientation, theoretically, this should be turning in the clockwise rotation. Now I'm going to get a pencil because I want to mark the corner. And I'm going to put an X on this side. When I put it back together again, that means that this X should be on the back side. And we're going to see if I can actually get this to turn counterclockwise. Now I'm going to just take it out of the vise. I've got a cordless drill handy, and we're going to take it apart. Okay, so we take out the rotor. We're going to take this apart. I'm going to change sides, flip my stator around, reinsert my rotor, making sure I'm into the bearings. And we're going to put it back together again. Okay, so in theory, this should be turning in the opposite direction. So let's go back to the vise. I'm going to reinstall it. I want to mobilize it. I'm going to put the fan blade back on. And we're going to give it a little bit of voltage. And what do you know? It's actually turning in the clockwise rotation now. And again, did this change the torque output? Not really.